Wait, is that a background?
What?
Hold on, hold on.
What?
Is that my background? Why is it a square? Why don't you just make our heads work?
What are you talking about?
Do the green screen thing on
Like
my.
you have to. So to do the green screen thing,
I'll give my settings.
you have to turn off yours. I'm just feeding your camera feed in. So they right. So then I have to go into OBS. We're live now. So if you want me to dig around with this, I can do that instead of doing actual stuff. But yes, in theory, I can go, oh, well, yeah, it needs to be green. But if you give me your settings, I can make you float.
That's all I'm gonna do. Okay, let me try. Wait.
Let's do that. Let me show everyone how we do this instead. So let me get.
Ah! Yeah. Wait, are we on YouTube? Send me a link. Amateur hour. Is it live? Send me a link. Let me see it. Oh, it's nice. Wait, where? Is it best to just send this as a screenshot? I don't know. You could. Yeah, I will. Turn my screen off. This? No, it's not. It's like in a way, it's like this. Ghetto. What's on? No, it's not. No, it's not. Uh-uh. No way. It's no. It's there's a lag. Like on the camera, it's just the like on the Skype screen, I can see my background. Cut a square in the middle. Cut a square in the middle. Nice.
Go back to here. Look at that. You're floating on my screen.
Boom.
Well done. Well done.
Beautiful.
All right. So you look good. I did not set up my green screen because I didn't think we were going to bother. So you are
Have your
my AI
face.
virtual assistant in the bottom corner is going to help
This is
me
awesome.
do this work. So I guess we should Twitch this. We should tweet it. Did I actually get it? Let me tweet it.
I gotta turn the audio off on this thing. Oh, this is
You got to
YouTube.
mute the YouTube stream if you're
Yeah.
watching it on YouTube.
That's what I was like. Why is it echoing? I was like, okay, there you go.
Trying to make my laser slices breathe native. All right, tweeted. We'll see if anyone shows up. If not, they can all watch it later because there's literally no one watching right now, according to the stats.
Where is it? You tweet it?
Yeah, I just tweeted it. We'll see how long it takes for Twitter to send that out.
This will be the most unpolished thing ever.
Oh my gosh, this is the muscle that we're trying to build though. Whenever we just like are going to randomly work on
Yeah.
something code, we should just stream it, build up an archive.
I should put Skype on here.
What do you mean?
So I can see the screen.
Oh, yeah, exactly. All right. Still says only one person watching. I don't believe that.
Impossible.
Oh, moderators. Look at that. Interesting. Something for me to look at later. All right. So the basic premise here, right, is we want to take this library and make it work when the app has been native AOT'd. I hacked the absolute living crap out of this yesterday. So this is the change I made to the Razor Slices library to get it to render after it was published as native AOT in an app. Now, to be very clear, all the things that are native AOT incompatible, this library does. So, like, you basically go through the list of all the things. Like, I scan for assemblies and then I load them. I dynamically discover types without referencing them at compile time. I dynamically invoke methods. I generate dynamic code at runtime in order to create delegates that can create the instances of the slices or the Razor templates. So like, these are all the things that you just typically, you can't do that stuff when you're doing native AOT. So
But
how
they're
do
.NET things.
they're
Everyone
.NET
does.
things, right? They're the things that lots and lots and lots of libraries do. So like, how did I get it to work well? In my core sort of Razor Slice method, I have a static constructor for the base type that you interact with, like the Razor Slice class. It has a static constructor. Again, it's very hacky. And when the static constructor is invoked, which, anytime you touch anything for the first time on there, it just scans assemblies. Like, it goes, okay, gets the application entry point assembly, find all the slices in there, find all the referenced assemblies and scan all of those for slices. Oh, and by the way, look at the bin folder and then find all the assemblies in there, like literally the DLLs, and manually load them and find all the slices in there as well. It's like the worst
Okay,
possible.
show me that code. What did you do?
It's horrible. It's absolutely horrible. So
Did you legit find it on disk and load it?
yeah. So if I go into
Oh
this one,
man, no, I see it. Oh
yeah,
no.
it's so bad. So here's my static constructor, right? And yeah, so this one's fine. Like, get the entry assembly. It's fine, right? And then I add slices from this assembly, and then you get back a list of slice definitions. And then and so the thing that I did to make it not barf with native AOT, because this method here, get referenced assemblies, throws after you've published native AOT. It says, no, you can't do that. Like, it's just not supported. And so I had to guard that with this if runtime feature is dynamic code supported, which it turns out isn't an exact perfect match for, like, there is no runtime feature is native AOT published. That's not a thing. You can't runtime check for if you were published native AOT. You can runtime check if a feature is available in the runtime. And even though I'm saying runtime check, it's even a lie, because none of this code exists in the app after you've published it native AOT, because marking it as native AOT links up like a special build property with this runtime API. So what happens on this code? So what happens is, like, the linker comes through, right? And it literally sees this code in IL and it goes, oh, there's an if statement that's switching on whether this property of this API is true or false. I know as the linker that there's an MS build property that corresponds with this runtime feature, which also corresponds with what they call an app context switch. And like, all those things kind of line up because they've been documented as lining up and built to line up in the .NET SDK. And then the linker just goes, all right, I'll just remove all this because I know in publish AOT, this runtime feature switch is set to false. Like, it's basically hard coded for the purposes of this. So even though I'm saying like it's a runtime thing, it's actually not. Like, this actually all gets trimmed out at publish time. So that goes away, so it doesn't explode anymore. And this is where I was doing, all reference assemblies, and then the really horrible thing, which is scan the bin folder. I know, it's horrible. It's
ridiculous
horrible.
code.
I know, it's horrible. It's not needed. Like, I'm going to get rid of all this. Part of this is like, going through the process of unhackifying this code. And then it's like, it actually builds up the cache, right? So the whole point of this is that once I found all the slices, you build up a dictionary of all these of the definitions of these slices with like it's keyed by a string, which is the identifier, which is like a path. It's like the CSHTML file path usually. And then other details about the slice. Was it strongly typed? If it was strongly typed, what was the model type? Does it have any properties that are made using @inject. So I need a service provider to create this slice so I can set the properties. It's little things like that, right? So I hacked all that stuff out in its one commit yesterday. So I added that if that I talked about right here. And that's pretty much all I had to do there. And I had an overload of one of my resolve slice factory methods here. And then in my actual app that I'm publishing, I marked that as publish AOT, right? So that's what you have to do. You mark your app as publish AOT. And then this is where the real hackery landed, right? Because even though I can get the code to not throw from the point of view of I'm calling APIs not supported, all the slices get trimmed away. And what does that mean? Well, if I look at, I've got IL Spy open here, right? So this app, can I zoom? I can zoom in. This app, the way the Razor compiler works, right, is that if I go back to my app, I've got my sample app up here. And my sample app literally, shouldn't have done that. My sample app has a bunch of slices in it. Here, all these CSHTML files. And then the Razor compiler's job is to turn those CSHTML files into .cs files, which then get compiled into my app. But they get compiled into like a weird place, right? So if I zoom in on, I don't think I can zoom in on the left-hand side here. You can see that underneath this namespace in my app, there's this ASP.NET Core generated document namespace at the root, and everything inside of it is internal. But the names of all those types are predictable. They're based after the file name. So there's a slices folder in my app. The underscore denotes that it was a / or a \\, and then there's the name of the type. So I can predict the name of these types even if I can't
zoom in.
reference them. I can't.
You can zoom in.
Let me. Does
that work?
Let me try something.
It is blurry on the feed.
Let me have a look.
Let me try putting on 1080p. That's why.
Oh, did you not have it on 1080p?
Apparently, it just chose 720.
That's pretty bad.
It's clear. It's just small.
I'm trying to get zoom it to work while I'm doing it. I'm just fumbling around with it at the moment. Why is that not? It zoomed the wrong thing. That's so funny. There we go. How's that work? There you go.
Yep.
So you can see, I think this is the one I want. Oh, I just crossed it out. That's not what I want. I think it's this one. No.
Aha.
Cross that out. Look at me fumble. Nope, that's a line. It'll be the last button I tried. There it is. So these are the actual types that were generated by the Razor compiler. They're in my app, and they're all gray because they're internal. That's what the Razor compiler does. It makes internal this for CSHTML files. .razor files are different. But they always go into this root namespace called ASP.NET Core generated document. The other trick though is they're what's called unspeakable types. So I can't reference them in my own code. So even though these types exist in my app, I can't, if I go into like my program main of my app, like I can't see them. I can't go ASP.NET Core generated. See, like they're not there. Like I can do ASP.NET Core and they look like they show up, but that's the wrong namespace. Like we saw in IL Spy, it's ASP.NET Core generated document, not ASP.NET Core.
Why is it showing up? What is that? Oh, design time.
Design time. So at design time, we generate this thing. But if I was to try and like reference that, I think what you'll find is I get a compiler error. And if I don't, then I have no idea how it's working. So like there's an error. Yeah. See? The type of namespace, blah, 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 doesn't exist. And the thing is, like, I don't even get a squiggly. Like, it's just really, like, it's not mapped to the right place. Like, it's just like, it failed. And like, yeah, it's not particularly, it's not predictive. Like, you just can't use these. They're not designed to be used this way. And so in order to route them so that the linker doesn't remove them, I did this, right? Which is what you told me to do.
Yeah.
I created a method.
Show me the code that loads the assemblies again.
Yeah. So if we go back here.
Are you looking at the assembly entries for the Razor compile items?
That's correct.
But for every assembly?
Yeah, that's right.
Just look at it for the same assembly. Just look at it for the main assembly. That's actually much better.
Well,
scanning the world.
That's of course until you have a Razor class library.
Yeah.
And so the other code, that's what I used to do. Is it literally just used to do this part? Right. It just did this part. Just like get the entry assembly. Because when you say type of, you were going to say type of some type in the app, right?
Yeah.
but there's no
Program.
API being called here. This is
Yeah,
just
that's why it's magic.
that's why it's magic, right?
That's
And so
awful.
that's why this kind of needs a little rethinking. So like even though this works now, I can actually run this app after it's been published, and the app works. Like all the razor slices render, you get a whole bunch of warnings, right? Like because the linker gets really mad. So like if I actually go ahead and I try and publish this app, you'll see that while the app runs, it's not particularly happy. So if I go into the samples folder in here, and I go into my web app, and I publish this for .NET 8, the native AOT part doesn't happen until you publish. And so it's going to go through, it's going to do a build, and then you're going to get to this, there's my stealer, and then, okay, null ref, ignore the null ref. So, okay, this is the wall of warnings that we're getting from, because we're now generating native code, right? So this step here where it says generating native code, that's the part where the native AOT stuff is happening. And the problem now is that I got a wall of warnings because it's detecting all this code pattern sort of going on that's probably not safe. But it published, and then I can go ahead and run it. So if I look in like the bin folder, look, there it is, that app, and I run that, the app is running, and then I can, in theory, if I pick a browser and I try and run this, look, it runs, right? There's my razor slices sample. I can click around. The footer is coming from a sub slice, so I'm rendering a slice from a slice or a partial. Like it works. Like there's nothing wrong with it. It absolutely works because of this hackery. But this is not good enough for a class library. Like you can't, like as a class library author, I want my razor slices library, if it's possible, to make it work in native AOT, which we just saw it is. How do I get a good experience for consumers of that, right? Like how do I make this, do it the right way? So that's the question. How do I do this the right way? Like what's the right way to do this? Like I'd have to go through, do I just turn on the analyzer and like start working through all the errors?
That would help her.
Okay. I mean, it would help with some of those yellow warnings, right? It would help with some of this stuff.
It would just tell you that you're wrong, but wouldn't tell you how to fix those errors.
That's true. So what you're saying is it'll just tell me these errors.
Yeah.
Again, in the editor.
Yeah.
But at least it'll tell me where they are, which is good, right?
Yeah.
And then I can go through, and I guess we could then go and talk about.
And you can realize that nothing that you would do from there would help.
Well, I'm going to assume some of these things are just I need to annotate my method with the same requirements as the method I'm calling. In fact, a lot of these are the warnings saying the source value must declare at least the same requirements as those declared on the target. So if that's all my warnings, this is going to be really easy, right? Because I just have to match the method that I'm calling. So why don't we start there, or do you think we should start somewhere else?
I'll tell you why. We should just for the feed, but it won't help because there's never a point at the root of the application where the compiler or linker can see the actual static type.
Right. So this is
in strings.
So here is my app, right? Here's the root of the app. This is my sample app in this repo, and there's all my map get calls, and you can see how razor slices works today, right? So you can see this results.extensions.razor slice, and you pass in a path. Like that is how my app, or the consuming app, references the slice. The problem is, as you're pointing out, this isn't a type. It's not a type, and it's not even the name of a type in a string. It's just an arbitrary string from the compiler's point of view. It has no idea how to map this back to that hidden type that I showed before in IL Spy. And so we have to figure out how do we route these types so that the linker can see them, right? So that the tool chain sees them. And that was this hack I did before to prove that it works, right?
So this is a static association of those strings to actual types. And those types are expressed as strings here too, because there's no alternative, I guess, for Razor.
There's no alternative.
They're internal.
Right, because they're internal. Oh, well, not that they're internal. It's because they're unspeakable.
Right.
If they were internal in my app, I could reference them here, and that would be fine. I'd have a generic method, right? And I would just do that. But I can't even do that. So, but we have. This is what you do when you can't do that. Like this works. You use this dynamic dependency. You say, I'm going to need all the members. Like don't trim any of these members here because I might access them dynamically. And then you say, this is the type name and this is the assembly name. But obviously expecting the app to do this is unrealistic. We need to figure out how my library can do this on behalf of the app, right?
Yep.
So
how do we need to generate this? So a couple of things: you need to suppress the warnings. If you have any code in your app that does warn, goal is to figure out where those come from, and can you elide that entire path completely, or do you just suppress the warnings for these?
Or instead of suppress, like just add the annotation it's telling me I should be adding.
Yeah.
So that I match the caller, right? And the reason, my understanding is that I am calling an API. I'm a library, and there's an app consuming me, and they'll from NuGet, right? My app, my library calls APIs in the framework, and those are annotated with like attributes that tell, hey, I'm going to dynamically access this, or I need this runtime feature. And then the linker and the analyzer can see that. Now, the analyzer, though, it can only see that for actual code, right? So if in my app here, my sample app, if I was referencing my library as a NuGet package, it can't see the code because there's no code in the package, right? There's no C#. The analyzers work on C#. They don't work on IL. And so it doesn't help if my NuGet package isn't what's the word? Flowing, enabled. I guess. It's not flowing those attributes from the APIs I'm calling through to my API surface level so that the analyzer running in the context of the app can see that it's calling something in my library that has this requirement. You're going to get this warning when you publish because it's going to go, hey, like A calls B, B calls C. C is annotated as requiring this. A is calling B that calls C, but B is not annotated that way. You need to go and update the annotations on B. So that's most of this yellow wall of text is what I'm seeing. And to fix that, I have to set a property in my class library, which becomes my NuGet package, that says, hey, I'm going to publish this. I'm going to be native AOT friendly. And then that will enable some analyzers so that I can see this in my library, right? As a developer of the library, is my understanding. So like I'll go into the razor slices here and I'll do like do you even know what it is? Do you know what it is off the top of your head?
No.
Let's see if I can figure it out. Let's see if I can figure it out. So like it's .NET native AOT library property. It's like, is native AOT friendly or something? Where is it? This is in publishing, which is the wrong one. I want the one for library.
You want the one in the CS project.
Yeah, but it's this not. I don't want the one for my app. I don't want publish AOT. I want the one that library
enable AOT analyzer. Sure.
Is that what I do?
Mm-hmm.
I thought there was another property that would also set a flag in the package or in the assembly, not just turn on the analyzers.
What does that do?
I thought that isn't there a doc here about the linker and how to prepare a .NET library to be trimmer friendly?
The linker? No.
You sure? Leveraging trimming to make... No, not that one. Prepare .NET libraries for trimming. Here we go. This one.
That isn't important anymore.
It's not at all?
The trimming is a different thing, right?
It's related, though. My understanding was there was an is something property here that's similar. So there's is trimmable, which you can do true, which will also turn on the analyzers. But I thought there was like a higher level one, which was like is native AOTable or something. And it did a thing. But now you're making me doubt myself.
I don't think so.
Interesting.
Because I think this does... Hold on.
I think there is.
This looks like like a specific flag that we... What is this thing? No, maybe that's right. Is trimmable? Maybe it's the one you want?
It is just that one?
No, I'm not sure. I'm looking at MS Build ridiculousness.
Oh, you're trying to figure this out by looking at the source code of the SDK.
Yeah.
I thought we had a thing. I was almost certain.
Enable AOT analyzer. I mean, maybe a better way to look at this is the YARP one, because YARP did it to YARP recently.
Oh, you're looking at our own libraries to see if they sell this? Yeah.
Eric did this to YARP recently. So I think it is. Is AOT compatible true?
There it is. I knew it.
Yep.
So here's the thing. Is that dot?
I don't know.
.NET is AOT compatible. Okay, so introduction to AOT warnings. Okay, so it's in this document here. Native AOT deployment model, intro to AOT warnings. Is AOT... Oh, it's not. It's actually not there. I searched for it, but it didn't actually come up. What did I search for? Is AOT compatible? Oh, that's unfortunate. All right. Is AOT... So that's not... So if I do that, that should enable both sets of analyzers, is my understanding.
Yeah, I think so.
So if I do so, look at all these warnings. I get 7 warnings now. Oh, that doesn't look good. So this is I think this is a known issue to do with the current preview builds and some versions to do with like using the linker analyzers. And so I don't know, we might be dead in the water to start with. Oh, I know what it is. I think I have to condition this based on the TFM.
You support multiple TFMs?
Of course I do. Razor slices, why wouldn't it? Like it's just a library that works on what are you shaking your head for?
Over-engineered. That's what it is.
Oh, listen to it.
You absolutely don't. You don't even use any APIs in those things that are specific. Do you?
In what things? I do actually.
6 or 7.
Yes,
what do you use in those APIs? What do you use in as specific?
I use UTF-8 span formattable.
Oh, you actually use span formattable.
I do. Like this, the whole point of this was to use all the new stuff, right?
I see. That's fair.
Thank you. Yeah. So I use static interface methods, which are only available on .NET 7 and above. So
yep.
Hence 6, 7, and 8 because I use things in all 6 is the base. I use stuff in 7. I use stuff on 8. Actually, I think I lied on 7. That's in Nanorm. I don't think that's in here. I don't know what I use from 7 specifically. All right. So I turned that on. So then if I go and change my context to 8. So here we go. Here we go. Did you see everything I just had to do then to get that to work? Yeah. Yeah. So I had to condition this. If you try and set that on in anything other than .NET 8, you get like version mismatches between the linker tools and stuff. Like it's not a good experience. And then I had to see them in here at design time. You have to make sure the current Roslyn context, right, is set to the same thing. So I have to make sure that this up here is .NET 8, right? And now look at that. I got a wall of warnings. I got 21 warnings. And so here's a good one, like entry.assembly.location says, hey, that's always going to return null in the context, or an empty string, sorry, in the what's it saying? For assemblies embedded in a single file app, which native AOT apps are single file. So if I need it, consider calling that. I don't need... Well, I think this code should all be deleted.
Pretty much. Not much you can do to fix this.
This is my bin scanning code.
I mean, I think the way you fix this normally in the AOT world is you put it in a method and you suppress the warning. And that runtime check is what the scroll up, the is feature check is what saves you from it ever running.
Right.
And
or
that can't be seen.
You put it in another method. You make the user call it.
And suppress it.
No, not suppress it. You annotate it. So you put it in on another method that has to be called by the user rather than in a static constructor. And then it's only if they call it that they'll get the warning, right?
Yeah.
Otherwise it gets trimmed away. So I think
the thing is this code is safe, but it's not known to the linker statically because it isn't following that branch.
Because it's not following this branch. So you're saying if I put all this code just to fix this right now, oh, hang on. That won't fix it. There's really no way to do this with refactoring.
You have to suppress it.
I have to suppress it at the method level. I see.
Yes.
So I would refactor this into a method, right?
It is, I know what I'm doing kind of thing.
This is unfortunate, but okay. Why doesn't it follow? Why doesn't the analyzer know? If
Did you write the code?
the linker knows about this, like it knows, it'll just trim all
should.
this out.
It should know.
It should know, right?
Yeah.
Okay. How do I move this? What am I doing wrong? Quick actions and refactorings. Why can't I? That doesn't do anything. Am I not supposed to be able to move this to a method? I was trying to use the tools.
Broken. Control RM. Extract method. Maybe this is broken.
Yeah, it did nothing. Oh. Oh. Okay.
It's may produce broken code. Maybe you're capturing state it can't extract.
I'm calling local methods. That's what I have, a local static method down here. That's fine. So I just have to do it manually. So if I just zoom out. So I guess I would just put the whole thing in? Or would you put the whole thing in, or would you just put the body of the if in a method?
What do you do? What is this thing doing? What state do you mutate? The slices definitions?
Yeah. This is adding to the global list of slice definitions.
It should be able to extract it, I think. I'm not sure why it can't extract it.
I think it's because when I selected it, I didn't select there are these local functions that are in the body that it calls. So we can't move them out and then reference this. It won't work.
I can't hear you.
You can't hear me?
Is that me or is that YouTube?
Let's have a look. Hello, can you hear me?
Let me ask them if they can hear.
Can you hear me?
Yep.
Somehow reason my Skype got muted randomly. I don't know why. All right. So it's because I've got these local functions, right? So if I moved out just that bit, then these local functions obviously can't be called from the new method I extracted it into. So I just have to hoist these up to be actual static functions on the whole class.
So our team members are watching, and here's, I'll pass you the thing that you can actually show in the stream to show people why this does not work today.
What's that?
We don't follow the code path in the analyzer. So you still get
the bug. So there's a bug right here.
Yeah, there's a bug. So you have to write code that basically warns if you call the method and then.
Did you know about this already? Did you just search for it?
Yeah, I knew. I mean, I saw it when we were doing all the changes to ASP.NET Core.
All right. Well, I'm going to subscribe to this issue because now I just got hit by it.
but
it's literally the first thing I hit. It's like, oh.
This is important if you want the library to run in both modes.
Yes.
If you plan to make it work one way and like remove scanning, maybe you would just use the source and never have this code. But if you want to keep both branches, you need to do this thing where you're like, if you're in dynamic mode, do one thing, suppress the warning because I know that this code path is safe.
Right.
And then else do other thing.
And I might end up there. I guess like this is like iteration, right? So like it might be I could instead decide to like go back to pen and paper and like do a redesign and decide, hey, I'm going to land on a design where there's no implicit discovery. You know, no matter what model you use, even if you're not using native AOT, you have to like call a method somewhere and that does the discovery. And if you want it to find references, you have to give me a root type, like a T, in order for me to find the assembly in there. You know, it's so on and so forth, right? And even then, I would have to source generate in that scenario in order to root all the other types in that assembly that I'm going to find. So yeah. Or we could just do this iteratively. We go through and then we redesign as necessary in order to get through the next layer of the onion, as we say, the onion peeling.
At the core of it, we need to generate something in the user's app.
Yes.
That roots all those types that were genned by the source generator.
Right. Generate something that can be statically seen as being called. It has to be generated in the app, has to be called by the app. And it can be called by magic, like by method overload hacks, or interceptors, right?
Or module initializers.
Or a module initializer. Or it can be called explicitly. You know, you can just say, hey, to use this thing, you have to call this method that doesn't exist until you reference my library and add a slice, because then it will generate it. But that may be not the best user experience. That's my concern about that pattern, which isn't really a thing that we have. Although you could argue it's somewhat similar to the JSON serialization stuff, where you have to declare a partial context class that has to inherit, then you have to put an attribute on it.
Yep.
It's like, yeah, like and then you have to use it somewhere. Just having it doesn't do anything. Or, you know, it doesn't complete the circle. So
what do you want to do?
That's a great question.
So the most minimal change would be, oh my gosh, it's static.
Well, the most minimal thing I could do right now, right, would be, say, for now, in the native AOT scenario, you don't get any dynamic scanning from anything other than the current app.
Mm-hmm.
And then, so we basically get rid of all this code out of that code path, out of that scenario. Yep. So when you publish AOT, none of this gets called, right? And we would just do the refactoring. And then that limits what we have to get generated to be just stuff in the current project.
Yeah. Right? It doesn't change much. I mean, it gets rid of this horrible code, but like...
Well, all it really does... It's actually... The thing is, the work required to do what I just said, you may as well just make it support this scenario as well, like the reference assemblies, because once you're source generating...
Yeah.
Right? So you may as well do that. The bin scanning is stupid. Like, this should just not exist.
Yeah,
like,
you don't need that.
I should just delete that, is my understanding, right? There's just really no... So I didn't even know why I added it, honestly. So I'm just going to delete it. Like, I don't need that. It's not needed. If you want to be able to just copy an assembly of razor slices into the app and then run it and have it be found, no. Like, we're not doing that. That's not a pattern that we endorse anymore anyway. We don't support it in ASP.NET Core for anything, I think. But there are libraries that exist today that still work that way. All right. So then we're just basically left with, other than these warnings, which we can go through, I need to write a source generator. Right? So to replace this code.
That code you wrote is not transitive. You know that, right?
The reference, this code?
Yeah.
Because I'm not walking the graph. I'm just getting the reference assemblies from the entry assembly.
Yeah.
Yes.
It's jank.
It's totally jank. Absolutely jank. There is just enough code in this library to support this sample app. And the benchmark. And then whatever issues people have logged, which is not much. This is a very iterative. That's why it's version 0.6 point something. Yeah, so to do this properly, this would just have to be recursive, right?
Yep.
Which is not a huge change. It's not a big deal. But if we're going to change all this to not do it at runtime, but do it as a source generator, once I've done that work, it may as well just do that all the time, right? There's really no advantage to having it work one way and then another way, depending on whether you enable a thing or not, right? May as well just make it use a source generator all the time.
So how would your source gen work?
So this is the issue. The fundamental problem with saying all that is that it changes the usage model of this library. This will no longer work. What I have here just fundamentally won't work anymore. The calling pattern, if I just make this a little easier to see, let me just focus on this section down here.
Zoom.
All right.
Zoom.
So here, this I commented out the one that I usually use. So this is what you usually use, right? Map slash to the result of calling this template. That's slices / todos.cshtml. That will not work anymore unless this method could be intercepted somehow.
Right. And what would you do in the intercepted method?
Right. So then in the intercepted method, you could imagine you generate the map, like you generate a big data structure somewhere else in the app that has a map of these strings, the type the view identifiers to the underlying type. And then the intercepted method would just look up like
the slice by name.
The slice by name, and then it would effectively simplified version, but it would call activator.create instance on the type. And then based on the other type metadata, like does it have a strongly typed model? Does it require injectable properties? I either throw if you didn't pass the extra context required. Like if this is a strongly typed slice and you didn't pass the matching model, then it would throw.
Yeah.
Right? And what's great about if I do this as a source generator is I've done 80% of the work to then write an analyzer that can detect that here as well.
Yep.
So it could go, oh, yeah, you're calling a thing and you didn't pass it a model that it requires. And then I could do a control dot to fix it or something, right? So that's one advantage of taking that approach. So that could work as an interceptor, right?
How would you find the slices in your source generator?
So the source generator itself would get access to the Roslyn model of this project's code, right? Which includes all of its references. The problem is Razor itself is a source generator.
Yeah.
And so I can't find the slice, but the type names are predictable. So I can generate the map, and then I can generate code that deals with it in a late bound fashion, I guess is the way to put it. I still have to, I can't get around the fact that I'm going to be dealing. That's fine. I have to do that already, by the way. Like even without native AOT, everything here, everything in Razor Slices itself as a library deals with these things as their base types, right? So when you build todos.cshtml, right? Here it is. You mark it as inherits from Razor Slice HTTP result of to do array, right? This thing, this class derives from Razor Slice of T model, which derives from Razor Slice. The actual logic in the Razor Slices library just deals with these two types. It's all it needs, right? Because it basically just calls the execute method.
Yep.
And very selectively will, lazily activate properties based with the @inject thing, which is just if the type has properties that are decorated with the attribute, satisfy them with the service provider. That again is just generated code, late bound code. So, but that stuff all worked. Like it didn't not work. So
the problem is that you have to replicate discovery of views, and then you have to generate the names that the Razor compiler will generate.
These ones.
That's essentially what this source gen does.
So basically this block, I have to generate this, which is not a huge deal. Like it's, as I said, it's predictable. The generator can see the CSHTML files in the project.
Yep.
Right? It can, there are APIs to let you get the files. So I can say, hey, find all the CSHTML files in the current project context. I could also probably say, find all the reference projects, go through the full graph and find all the CSHTML files. So I can build up this map, right? And decorate whatever method.
Can you see files in other projects? I'm not sure you can.
That's a great question. I don't know.
I don't think you can. Maybe you can. Maybe you can walk project references specifically.
I mean, it's not a huge problem. If I can't, then it simply means that the class libraries, they also have to have the source generator enabled.
I think so. Yep.
And then I need to figure out, well, great, how does the consuming library find? How does my source generator find the generator method from the other thing, right? Like then it's a question of flow. How do I flow that from my reference project into this project, which ultimately again is is a like, what API are you calling? Do I just make them call an API that says, hey, add the slices from this class that was generated by the source generator in my class library, right?
This is the issue with source generators.
Yes.
You essentially need to generate a declaration and then they have to compose somehow. This is like JSON in a sense that,
yes,
imagine you had to declare a type, a partial that was like a stub.
Yeah.
And then the source gen would just generate another partial class of the same name that had these attributes on them. And then you would have to pass in this thing somewhere.
So imagine I did this, right? And then usually the pattern would be, Razor Slices something generated or something. Like you put some attribute on it, right? And then that's what triggers the generator to run. And then the question is, great, so that in some hidden file, there's a bunch of code in here now, right? All this stuff that we just talked about. Great. What do I do with this slide? Like, what do I do with this class? Like, where do
you got to pass it somewhere.
Right. So I would have one of these in my Razor class library. So this project up here, and I'd have one of these in my app that references that. So I've got two of them. So now I have to like combine them somehow so that I've got one big map of the whole world. And then I have to feed them into the place that actually
create,
like here. And then somehow it has to be fed into this call.
Into those calls. Yep.
Right. And that's what leads us to this, like the new C# feature, the interceptors feature in C# 12, which we're using in ASP.NET Core to make map get itself work. To make this call work, we, instead of calling the thing in the framework, we generate a different map get method basically in your project, right? But we don't support discovery of different map gets from a class library. That's not a thing. So we don't have to worry about that problem. But you can absolutely have types from another library that you want to JSON serialize from a map get in your
Yep.
project. And that has to flow. And the way you do that is you have to, in your other class library, create one of these classes, which in the case of JSON is a JSON serialization context that you derive from.
Yep.
And then you have to configure your app in its options to like stitch them together. Like you have to add them to the global list effectively in DI. So I could just mimic all of that, but I was kind of hoping we could do something a little less ceremonious. But
if you did interceptors, would that work well? You would basically have to generate the map in a way that was accessible to the interceptors.
Right, which is possible because this method ultimately is returning an object that will have execute result called on it, right? And so as long as the stuff that's generated goes into DI, I can get it back again. Or you have to pass in the generated thing to this call, right?
If you're gonna add the thing, yes. So I don't know if interceptors help here unless you.
Right, because if I'm going to pass it in, why intercept? Like, just make them pass it in.
Yeah, exactly.
Right? The only way it really helps is if rather than passing it in here, you make them configure it in DI. And then the implementation of this, which is now, well, even then, you don't need to intercept even then.
Exactly. Yeah. I think if you were to do interception, so if you were to write this method body with interception, you would generate the code for this specific
slice in here.
Slice.
Yeah, I see.
There.
Oh, that's interesting.
A big switch, essentially. Or like,
that's interesting.
For that slice, return this.
So that would basically, instead of having a global map, you just generate the code required to find and create this. And you put caching. And the problem then is like, how do you cache it, right?
Yeah.
Is because you don't want to do the late bound type stuff every time.
So you would have to have a map, but
how do you find it? Then you're back to the same problem. How do you find it?
Tied to you need a call to something in DI.
Right.
This is static though. Yeah, you're screwed.
Yeah. Yeah. So, like, with the minimal stuff, this delegate ultimately is, wrapped in a generated delegate, right? The one that we source generate, which lives in a map, right? Which is effectively keyed by this route, this string plus the location of this delegate, like where it is in your source code, right? It's kind of a logical way to think about it.
Yeah.
The question is oh, okay. But we're generating extension methods that live on a stateful object. That's the difference.
Yes.
Right? Yeah. Whereas here, I'm not. So if I wanted to do this, and then the problem is I can't generate a map get overload because that then can't compose with the one that's being generated from normal APIs.
That wouldn't work.
So this they do not compose.
Yeah. Plus, you can't even you don't really want to look at the body of the method to try and glean what to replace there.
Yeah, very good point. Very good point. Yeah, absolutely. Yeah, so even if I do generate an extension for this, because this is an instance object, but it's not actually, it's a lie. This is a marker object that we just use so you can hang interface like static extension methods off it. It's not really stateful. There's nothing for me to do the association. There's no state object. This is the problem. So even if I generate a method here, I can't tie it back to the map. I can't do anything really. There's nowhere to put cache.
You can, but you can't cache it as well.
Well, other than in a global static, which is the whole thing we're trying to avoid in the first place.
Storing a static.
Global statics, exactly.
So assume you can't do anything, but you need statics anyway.
Yeah. Well, because this call side is ultimately static.
Yeah. There's no state.
There's no state. I guess the only other, without putting something in DI. Without making them put something in DI, because then I could at least look it up per request. Like you could cache it in a concurrent thing, but then that's slower. I don't want to do that anyway. Like one of the other things is
you actually can cache. You do get access. Just defer everything.
I can defer everything, but I was about to say, currently I don't access request services unless I need to. Unless your slice has an injectable property on it, I don't touch request services. I fully delay the resolution of the request services property off HTTP context, because I know it's expensive. It's a one-time per request cost, but I'm trying to avoid it unless you need it. So I don't want to use the DI.
You can't get it. Show me your slice. The
actual
slice
code.
Method. Yeah.
Like which bit in particular?
For that method, the result type.
Oh, I'm sorry. It's So this literally. Remember the what I do is I have a version of the razor slice base type that is an HTTP result. So the way you have an HTTP result is you just make your view derive from the HTTP result class. So I avoid the extra indirection, right?
Yep.
So I just literally just cast the result. And this is, why I have to do this, right? Do you remember why I have to do this?
No.
Other than this.
Great.
The source generator for minimal APIs currently doesn't work.
Oh, the polymorphism, because
it doesn't work with polymorphism. Okay. So I had to make sure I return that typed as HTTP result. Otherwise it does, JSON serializes my slice, which isn't what I want.
Is that fixed yet?
No.
You sure?
I still hit it. No, it's not fixed.
No one fixed it?
Not fixed.
Okay.
So basically all this goes down into the create. This is all the activation stuff, right? Like just creates an instance of the T, where the T is take this string identifier and look it up in the big map. Find the razor slice type, right? And then it creates an instance of it and it returns it, and that's your result. And if that has a model, then it sets the model property. If it has injectable properties, it sets that using the iService provider, which it only does and evaluates lazily if it has those properties. So all that stuff kind of happens, and that's all in. Am I in the right method? I think I'm in resolve and create.
So slice itself is a result?
The slice itself is a result. Now, what I haven't shown you yet, and is also important because we're doing native AOT, I'm just trying to find it, is this whole concept of a slice factory, is this bit. So slices, because they're internal types that are unspeakable, how do you create them? Well, I have to generate code that calls their constructor, right? And then
oh my gosh, you also have the property things?
I have everything. Like I have all the things that make this impossible.
So
right?
add inject.
Yeah, that's what I've been saying. So add inject is supported. So like I have slices here that have add inject, like to do row. Oh no, it wasn't that one. Here we go. This one has add inject. Yep. That works, right? Because at inject at the Razor compiler level is actually really basic. It has no runtime dependency other than it generates the property. I can show you. It generates the property for folks watching. So this is the code. This is the class that gets generated by the Razor compiler for this CSHTML file right here, right? So here it is. So it slices Lorem injectable properties, which is the name of my file, and it just adds properties, right? For at inject, that creates a property, and then it decorates it with this Razor inject thing. There's no code in here to look in the service provider or use DI. That's all the job of whatever is rendering this slice, right? In this case, it's the base class itself that's doing it, but you can imagine, other models. It's just properties that are decorated with an attribute that says, hey, can you inject this for me, please? And so I have to generate the code that does that. And so where was that code? Here. I use link expressions currently to do that. As part of building that map up front, I build basically the factory delegates for every single slice. So that when you say render this slice of this path, what it actually does, it doesn't look up the type, it just looks up the delegate, which is the factory for that slice, and then it invokes it. It's as simple as that. Cast the result.
None of this stuff is going to be easy. This is like hard mode.
Now, I think because it works. The thing is, this works in native AOT. It works. Like this code is working.
It's just slower.
It's just slower because it does expression evaluation, right?
I mean, so you may as well just use reflection. That's actually faster than doing this.
When you what do you mean? But you mean do dynamic invoke?
Property info dot set property get property.
Really, that's interesting.
Generating a thunk.
It's better in native AOT. It's not better in core.
Better in native AOT because it's interpreted.
So if I was going to do anything, this might be where I have two code paths. I might have a code path because I can't even source generate this.
You don't have a choice. Yeah, exactly. Because
I can't source generate this because the types they're unspeakable. My source generator can't see them.
Yeah.
So, okay, maybe I need two activation paths. I need an activation path for native AOT, which you're saying just use late bound standard reflection.
Mm-hmm.
And then for core CLR, I do this.
Yep.
Which is compiled expressions. Okay.
Yeah.
Because this works in both, but this is slow. It's funny. One is
bit.
slow in core CLR and the other one is
know.
slow in, but they both work. Isn't that fascinating?
Yeah.
Okay.
Yeah. We're adding new APIs in .NET 8 for fast reflection. But I'm not sure they would work here either, to be honest.
Okay. You mentioned like using activator.create instance.
Is better.
Why? So why wouldn't I just do that in the native AOT activation path? Why wouldn't I use that? I could. But then I would use reflection to do the property setting.
Yeah.
Okay. Well, that's a bit easier because then I don't have to worry about find all the code to find constructors and stuff. I just call activator.create instance and it'll throw if it can't find a parameterless constructor anyway, right? Yep. So, okay.
Do you cache? This currently isn't cached, right?
Yes, it is.
It is cached today. Where is it cached?
So this all gets generated, right? And then it's stored in this slices by name read-only dictionary.
Ah, got it.
And it's keyed by string. There's another one by type.
It's not concurrent.
It's not concurrent. Why is it not? Why is it not concurrent?
You did it once.
Because it's done in a static constructor once up front. Now, one of the other features I'm going to add requires it to be concurrent though, which is support for hot reload.
Yep.
So I have another branch where I started, implementing. It's actually very little code to support receiving the message from the tooling and the metadata updater or whatever it is. The problem is it's fully concurrent, right? So you might get that message in the middle of something else and you need to be able to clear this cache in a concurrent friendly way. So I probably need to, I don't want to lock. So I need to put that I need to change this to be concurrent. The thing is, if it's concurrent, then it suggests, well, maybe I shouldn't do all this up front. Maybe I could change it to be lazily discovered.
Lazy.
Yeah, like per.
It's a trade-off.
It's a trade-off, right? Because the problem is, because the call sites are giving me a path, they're not giving me anything I can look for without scanning. I have to scan. So, but I guess if I'm source generating, no, that's not true. Because I can source generate all the keys up front and populate the thing and then lazily populate the values. Right?
What are you source generating?
So I have to source generate anyway to route the types, right? I have to do that. I can't get around it. I have to source generate
what though?
I have to source generate at least a method that is decorated with the dynamic dependency attribute. I have to do this. If I don't do this, nothing's going to work because it'll all get trimmed away. So that means I've already generated the type names. Like I already know these names.
Yep.
And in the process of generating this, I can discover. No, I can't. Sorry. No, I can. I can scan the CSHTML files and I can figure out what the ID will be. Right?
Yeah.
This is how I'm generating this, right?
That's the assumption, right?
So I know someone will call render slice with /slices/Unicode. That will be a call that might exist. So I can put that.
How do you map the are you looking at each of the files looking at the route attribute?
Yes. No, not the route. There's no routes. Sorry, Slices doesn't support route. It's designed to be
page-based. Oh, it's not. No, you're right.
It's not like Razor Pages.
File.
So the generator would look at the CSHTML files, look at the path of each of those rooted at the project, then goes, okay, well, that's going to turn into this type name. It's going to turn into this project root relative path. I need both of those.
So you're mapping the path to the type.
That's right. And so then the concurrent map, its key is the path, and this thing needs the generator type name. So then I could create the dictionary up front, the map, it's source generated, it's just like there, you call it and it's there, but the values could be lazy. But for hot reload, it's the same problem though, because hot reload can add types. So you could add a new CSHTML file, and then I need to add a new one to that thing. So I guess
then your source gen rerun?
It will be rerun, right? And so not only will that type be the slice be new, but the generated code will be changed, right? So that type will get updated as part of the hot reload patch as well. And then I would need to
I know nothing about. Would that just work? Or
no. In the sense that the patch will get applied, but if no one calls it again, it doesn't work. So what you typically do is there are two notifications from the hot reload mechanism. There's a metadata updated or application updated one, and then there's a clear caches one. And you typically implement both. and you can decide what each one of those does.
So what happens when you add a file? So F5 is running, you add a file.
Yep.
What happens?
So what will happen, right, is you add a file, my source generator will run in VS, right, and in the design time build, the compiler, and the Razor source generator runs. They both run independently, right? Because there's a new CSHTML file. That will result in a new compilation that contains the delta from the last one will be a new slice type, like a new row here, whatever the new file was, and whatever changed with what I source generated. So if I'm generating some global map of stuff, like that type will now be changed, right?
Right.
So there's a question there, which is the way I'm writing that type friendly for root edits? Like if I imagine that scenario, is that even a delta that the hot reload mechanism can apply? Or am I using some feature of C# where it just goes, no, you can't change a private field, concurrent dictionary instance, whatever, like whatever it is, I don't know. But I have to think about that. And let's assume it does. And then it's like, okay, well, it patches that type. It sends that delta into the running app, calls the runtime method via the debugger hook and says, here's the new stuff, patch these types. The Razor slice will be a new type that's added. The generated code type would be updated. It'll just patch whatever methods or members got changed. Then the question is, well, okay, in my handler, my metadata handler that's in Razor slices, which will get called by this mechanism to say, hey, stuff changed. What do I do? Like, I have to basically reset the world and reinitialize global state. That's what I have to do at that point. Which is what MVC does. If you go and look at the hot reload handler in the ASP.NET Core code base, there's literally a type called hot reload handler. And it gets given the list of Razor types that were changed. Because the extra thing that we do there is that we mark CSHTML types. The Razor compiler marks them as reloadable. And in hot reload, that has special meaning. It means that it actually generates a new type rather than patching the existing type. And it means that you are less, and because there's indirection, because you're not referencing these types directly, it can just say, hey, this type slices underscore Unicode, I just replaced it with slices underscore Unicode underscore 1. So do whatever you have to do in your internal state to update your maps where you were previously returning slices underscore Unicode, you should now return slices underscore Unicode 1. So I would use that mechanism because it means that any code in a CSHTML file, basically there's a lot more code changes you can make because you're not limited by the edit and continue compiler limitations because it just generates a whole new type. You can always generate new types basically. And so it's much more compatible. There's much less causes of root edits. But to support that, I have to think about the code I emit to support native AOT. Because if I do that
I'm not sure. What does that mean for source generators? I haven't figured out how those things collide yet.
They just run as in my head. Because what happens, right, is part of the as you said before, when you run the app, you hit F5, a full compilation takes place, you get a real app assembly, it gets launched onto the debugger, and then there's like a design time compiler running, right, in the debugger. And so when I make a code change and I hit apply hot reload, that tells Roslyn to do a special type of compile. And it does a diff compile, right? So it says, okay, well, I know I launched with this compilation. I know they've changed this code because they're tracking literally every file, every buffer, not even the files. They're tracking it all in memory, every editor. And then they do a new compilation and they give you a diff. They say, okay, the only thing that changed was he changed like one line of this method on this type. So here's the delta. Just patch this method with this new body. And then they give that to the debugger, to the runtime over the debugger channel. And then the runtime does whatever it does internally to patch methods, some IL stuff, and so it'll get rejittered. And then it fires the app. And then it tells the app. If it has a metadata handler registered, it'll tell the app, and then the app does whatever it's supposed to do to make sure that that gets called. Because the whole thing is, yeah, you may have patched the code, but if no one ever calls it, you're never going to see the effect of it, right? So you either have to like clear caches or actively call it, or clear caches meaning that the next time someone tries to use it, you lazily go off and populate it again, which is what led to my whole, well, maybe I shouldn't do all this up front. If I do it lazily, it means handling hot reload events might naturally be easier.
Yeah.
Right?
Because you assume it's dynamic.
Because you will always assume it's dynamic. Exactly. So Yeah.
So you always have to do reflection. You can't get away from it because the types are internal until we get that new runtime feature that lets you instantiate internal types and do fast reflection over internal properties.
That feature still doesn't that feature still require you to be able to reference the type? I thought that was about internal members, private members, like getters and setters.
Are your properties internal? I guess they're public properties just on an internal type.
So these are the types. Yeah, they're public properties on internal types, but it's less about they're unspeakable. And they're generated by a source generator. So even if they weren't unspeakable, my source generator can't see them.
Yeah.
But I wouldn't need a source generator if that was the case. That's the difference, right? If these were source generated as public types that the app then referenced, I wouldn't need a source generator. It would be fine. But because they're not, everything is lazy and late bound. It makes everything that much harder.
No, it's not harder. I think we learned some things like no matter what you do, you're gonna have code that calls create instance and sets properties.
Right.
That's like a given, no matter what. That we want to be cached, so it happens. Actually, there's no point cache now because you can't cache the reflection anyway. You could only cache things like grabbing the property info, so that there is a cached entry per type or per string. Either one of them. Per type, probably.
Yeah, I have both right now, but no one really uses the type keyed one. Like, it's really the path keyed one is what gets used, right? Because you say render this slice, and the identifier is the path of the CSHTML file. Yeah. It's basically, it's like Razor Pages or MVC views. It's very similar.
Yeah. So the cache entry just has all the things required to instantiate and set properties on that type.
That's correct. Yeah. So if you assume you do the discovery at compile time with your source generator because it's deterministic, right? Like I can't see the types because they don't exist yet, but I know they're going to exist because the CSHTML files are there.
Yeah.
So I can generate the attributes that roots them, and then okay. Is that all that's needed? Actually,
you still have to gen that on a thing that gets called.
Yeah, sorry. So, like we said before, like this needs to be generated, and for this to matter, someone has to call it.
Yeah.
Right? So that still exists. And maybe, okay, what if that was the only thing we used interceptors for? What if the only thing we did was that, going back to the idea you had before, what if we generated an overload for this method, and all it did
was root that type.
That's all it does.
It's interesting.
And then you leave all the other stuff. You leave all the other stuff to do reflection based. It's all runtime reflection based, and you do the usual caching and everything else.
You know what it would allow for?
What?
Trimming of unused views.
Yes.
But you would have to root the transitive closure of used views as part of that type.
Oh, that's true, because
if you pulled in
partials, it pulls in partials.
Right. You would have to know at compile time what all the things that were used, or maybe on every method you root the entire thing. I don't know.
That was my first thought, is I just like duplicate it, but I'm like, oh, that's horrible. How about this? You generate this static method, and then you just generate overloads for these that all call that method first. Does that work? And then calls the actual version of this.
I think it would work.
So everywhere that you're calling this, it calls a know what method that only exists to ensure that these are kept.
Yeah, ensure these are.
Yeah, and right. So it's a little jank, but it doesn't add any cost, right? You're not paying any. I mean, you're paying a per request invocation of a static method that does nothing. But that shouldn't even be measurable, I would have hoped.
No.
Right? And it's just there to root. And then everything else basically works the way it does now, modulo the stuff we said before, right? Like, I would change...
No.
No?
They're two separate issues.
They're two separate issues. Right? But this would root everything.
You can't just intercept to root.
You can't?
Where's the map? Where's the instant? Like, where's Who stores the map from?
So then I can also generate a module initializer in the app.
Hold on, rewind.
Okay.
3 problems. One is instantiating the actual things.
Well, first of all, let's go in order. One is rooting them so they don't get trimmed away.
Rooting the types, right?
Second one is they're only ever being called with an ID like this. So given this ID, something has to know what the heck they are. Like, find the types and then generate and then instantiate them.
Instantiate it, right? Yeah. So I think instantiation, we understand. We use reflection in AOT mode. That works because the types are rooted and they haven't been erased.
The question is, how do I cache all that? We're back to the state problem.
Yeah, it's what do you do to cache the lookup from this to type?
Right. So let me ask you this. Why could I not just, if I'm going to be source generating an interceptor for this anyway, for the purposes of the indirection of the routing, why can't I have a static constructor on the type that I put the intercepted methods on and have that basically do what I'm doing already?
What would this do?
So the static constructor, which is effectively like a module initializer, right? Like it will do the scanning. What works right now, given they're rooted, it works, right? It
says no scanning, right? You're just going to look up.
Scanning for types, not assemblies.
Why do you have to scan anything?
Because I don't, that's fair. That's fair because I don't have to scan. I can literally just say load this type.
You know the type, yeah.
I know the type.
So the only thing you want to do is cache the type instance. You want to call type.
Not the instance. I want to cache the factory that creates the type. I want a fast method that says when I say create this slice with this ID,
this string,
it's as if I'd called new on that type. That's what I want, right? That's what you want ultimately. That's what we're trying to get to.
Although I don't know if you're gonna save much.
Over doing what?
Just emitting that code directly in the method, in the intercepted method.
Activator.create instance of the type name and then the reflection code in the native AOT case.
I think you want to cache the type instance and that's it.
What do you mean the type? I can't cache. Oh, the type instance. I see.
Type instance.
I see.
Yeah. So the code you have here. So let's mock it up. So write the razor slice overload thing. Do a fake.
Yep.
Razor slice extensions intercepted.
What the heck is it run on? It's like, was it razor slice? It's this call signature. Okay, so it's, oh, that's the wrong one. It was this one. And it's running on this result extensions. Yep.
Yep.
I don't even need that. Okay.
And then string.
And then this is the model version.
Yep.
But if I'm generating it, I would just generate it with the...
No.
No? Keep it generic?
It has to match.
That's what I'm saying. I generate it with the... I just do this.
No, it has to match the original.
Oh, it has to match for the overload. Sorry.
Yeah.
Sorry, my bad. Yep. Okay. Yep.
Yep.
Right.
And the string should be IDA or path or whatever.
Yeah. Right. So you generate that. And this, I mean, this won't work right. This would actually need interceptors to work. Because there's nothing to be more specific with here, right?
Right.
I can't trick it with overload resolution in this case.
Right. So you would do type.getType.
Oh, I need the map.
And that's the thing you want to cache. No, you all you want to do is cache. You want a static field that resolves the type instance in a static read-only field here.
Yeah.
And then use it in this specific overload.
I just lost your camera very strangely. Let me just try and reactivate it. Oh, it's back again.
Oh wait, I saw.
You're back again. It's all right.
Yeah.
Sorry. So say that again. I don't have it here, right?
Do a private static read-only field in this class.
Private static. This is going to be my map. Was this my map? Did you say?
Nope.
What am I
no
doing?
map. No map.
What are we doing?
No map. Private static read-only type.
Ah.
Call it like.
This is a generated name of some sort.
Type 0.
Okay. Yeah.
Equals type.getType on the name of the view.
So whatever this one is, for example.
Yeah. So grab footer. That whole. Yeah.
Yeah. Whatever. Yep.
And then that will be used directly in this method.
Okay.
And
hang on.
The way this works is
hang on, but I don't know.
You do. So you generate methods that are specific to a call site.
Oh, because they're all intercepted. Sorry, I see. This isn't one. Okay. I'm generating n methods.
A ton of different overloads, yeah.
So hang on, but hang on. I can't have two methods. Oh, they've all got different names.
They're all named differently.
Oh my gosh. Okay. I'm just catching up with how this is going to work.
Let's call it 0. Let's call it 0. It's much easier than giving it names.
Sure. All right, something like this, right?
Yep.
And so then this thing will call, it's going to use slice_0. It's going to create it by calling activator. Is this what you mean?
Yep.
I see. And then I have to set properties on it, maybe.
So how do you get those properties in the first place?
Reflection. Right?
Oh, you look at the type itself.
Once I've got the attribute, I go and look at the actual type as well and find any injectable properties.
That has to be cached too.
Yes.
So that's part of this thing. You would have like slice 0 properties.
Injectable properties.
Yeah.
I read only collection.
What? No, just make it an array. My God.
Oh yes, of course.
Property info array.
Yeah. And then this would actually be initialized like here.
Slice 0 type. No.
No?
I'm assuming you can't detect these. But if you can, then you can just do it.
I can't because I don't know the I don't. So basically I generate the code to do the reflection once, is your point.
Yeah.
And I just do it like this. It's literally this straightforward. Like you just
get properties where, and then you pay the startup cost because you don't have public statically accessible things, whatever the thing is.
Then you do this whole thing of razor inject, so on and so forth, right?
Yeah.
It's true. Get custom.
Not null. It's not null.
Yep. And then and I need to array that.
To array.
Hack. Yep. Okay. So then I've got, and then I can also, that's going to be, some slices don't have that, and that's fine because I'm generating this and that at the same time, right?
If you can know that there's no injects,
I can. Oh no, I can't. Yeah, I have to generate code that checks. So so basically,
it's always good.
If slice.
Now just do a for loop.
That's safe. Like it's fast, I should say.
For each is fine too, because for each gets turned to 4 for this thing anyway.
Oh, okay.
For arrays.
It does now, right? Look at that.
Tab. Look at that.
Gotta love.
It knows.
That's not even Copilot. That's just IntelliCode.
I know.
Yeah. So like, and then this would
prop.set value, whatever. Like.
Well, I need
How do you get the context?
How do I get the service provider? That's right.
Oh no. Here you create a slice. Sorry, this happens.
Execute does the setting.
Yeah. So you have to create a slice here.
Yeah.
Or.
So I have to set the model here. I have to set the model.
Yeah.
So I have to do slice dot. Well, this okay. So instead of doing this
as razor slice, I guess.
Yes. So I know, as razor slice of T model, right? And then I can just do slice.model equals model. And then this will be some nullability. Yeah, okay, and then I have to return it. And then that should be razor slash ACP result. Yeah, like so. Yeah. Okay. And I don't need this at all, actually.
Because that happens internally.
Actually, no. Hang on, let me think. No, I do need this. This does need to be done in here. It does.
Who sets the property?
So what happens today? Oh God, let me check. That's a really good point. I just did this last week. Oh, okay. So today, yeah, when I generate the delegate that creates it, basically the pseudo constructor that I generate for it, it sets the properties. Like it takes the iService provider in it. So there's a factory type that's like razor slice with injectable properties delegate, right? And then that takes an iService provider. Okay. The problem with, so I'm going to have to do what you said. The problem is, where do I get the service provider from?
So what context normally sets these properties?
Oh, no, that's how it works. Sorry. The slice has a service provider on it. It's just that, oh gosh, I got to remember.
No, I'm missing something. This must happen lazily.
Yeah. So if I go to here.
Okay, it must happen in execute maybe?
Look, yeah. Look. Okay. Where the hell did I do this? I did this the other day.
Isn't it in your thing? In your factory map thing? The runtime?
Yeah, you're right. What happens is if I go back and follow this all the way from here, this thing calls create HTTP result. That thing calls create with the slice MM model. This is what we're doing. That thing calls resolve slice factory.
Right.
And that thing has an implementation. This looks on the definition for the fact this is typed as delegate, right? The global cache just has like this is the factory, which was pre-generated up front with compiled expressions.
Right.
And then it says if it's, yeah, right? So if it was one that is a model, razor slice with name was found, but it's model is the wrong model type, right? Otherwise was not found, declare with a model, ensure the slice uses blah, blah, blah. So that basically catches the scenarios where you're using the wrong type. Otherwise, it just returns the factory. And wait.
Slice with services
factory. Oh, here we go.
That's it right there.
Yeah.
That must be it.
Yeah. So you have to call, yeah, that means you went down the wrong path. Yeah. See this one? So this one returns a different factory. So the call part.
That's why it works. That thing passes in the service provider.
Yeah. See this one?
F12 on that delegate type.
I am.
That thing.
I did. This is the only call. This is the.
That one.
Yeah. Yeah. It's this. Right.
There it goes.
Yeah.
That's why it works.
Yeah. So, but I'm trying to find the path that if you just say like render a slice. So the reason what I made work, I think, was that if you've got a partial, what I do in the execute result is I set a lazy delegate to get the service provider from request services so that if you render a partial, that's factory requires a service provider, it only then gets it, right? But if you're rendering a root one, there's every chance I'm just not even handling that right now. That you have to call a different method to render a root slice that requires a service provider. Let's have a look. Yeah, see, there's an overload. See?
You pass it in.
Yeah, it's jank. Like this isn't nice.
Wait, what?
Yeah, it's not nice, right?
Hold on. Does add inject work or not?
Not on the. So if I did, yeah, it does. It totally works. But you have to at inject works, but the original call site that created the slice, hierarchy
has to pass
the slice, has to pass the service provider.
It's jank
as hell because I don't depend on DI, right? So that's the problem. So
jank.
It's jank. What works?
Wait, so if I have it at inject, it doesn't work today?
It works on partials automatically because when execute is called, I grab the request services without actually evaluating it.
Yeah.
Right? so that you can call it. But if your root one has one and you didn't call this overload, it doesn't work. So it's jank. Like this has to be fixed. Like we need a different call pattern because I want to avoid what you want is that the implementation of this needs to be the thing that figures that out.
You can't avoid this. You can't avoid that. This is physics.
No,
physics.
No.
You basically need to not have this be static, or just use the request services. There's no real workaround for that.
I really hate
design yourself into a corner.
I really hate that.
You got to access request services.
I mean, I didn't do it. This is the minimal APIs design, right? Like this is
I know. This is why we couldn't cache. How did we solve that? How did we say we're gonna solve that problem? Oh, no one did my thing. I should add that feature. I forgot it now.
I did some spike of like you could have a results factory in DI, and then you could do a thing that way, and then you were like, "Yeah, I thought about this. We could do it like this instead."
What was the thing that? Yeah, what was that thing that we did?
I can't remember. It's in the chat
history somewhere. It's in the chat, right?
Yeah, because I spent like a day. I spent like a couple hours trying this one day.
It was about setting properties on the iResult that were internal.
Oh, that's right.
They were resolved up front and set as properties.
But that only works when you say that only works for things that are special cased.
It only works inside RDF. Anyway,
exactly. RDF has to know about them. It doesn't work as a general pattern.
It was for JSON and for log.
We could do it for things that we know are not scoped. What we said is that we should have, when we built iService thingy, IAM service, we should have made it also support lifetime. So you could ask it and say, what lifetime are you? And then we could have just generated this optimization for all of them.
It wouldn't help you here, though.
No, it wouldn't, because there's nothing in DI. So in this case, I mean, you know what I'm trying to do, right? I'm trying to make you only pay the cost of the service provider stuff if you need it. And the way I've done that is if you call it without it, it fails.
Yeah.
And it says, no, you have to pass this through, which kind of sucks because it means you have to accept iService provider here and plumb it through, right? Which is jank. Right?
I mean, maybe instead of doing it this way, why not just do it in execute async?
So that's what I half do, right? So if you look at,
or do it in the result itself.
So this is the execute async, right? This is the result, right? So I'm trying to remember where it does it. I did this code there.
Like here's where you would check for the properties.
I see. The problem is then it means that
resolve.
And so but that means there's different paths for creating slices. If you create a slice outside of the context of result execution, like who sets the properties on it?
It will be null.
But today, I know it's a layer down today, right? So that like the slice factory, you can resolve a slice factory up front. And then you just call the slice factory to get an instance of the slice whenever you want. And so you can resolve it in program main and then just have the constructor effectively. And if it needs a service provider, the slice factory will be typed as requiring a service provider. And then there's no lookup cost or anything, right? It's just all, you just generate it.
Yeah.
I think the reality is there's really no equivalent to that as we move through this process. I'm going to find where the hell I did this thing where I set the service. Oh, I know what I did. It's here. Okay. So I see how I set the context.
Yeah.
All right. So if I go to razor slice.service provider, that's how it's implemented. The slice is either created with the concrete service provider, or it lazily resolves it from context, or it's null because you have neither a service provider or a context. And that means the slice as a concept is not tied to a context or a service provider. That's what I did to try and avoid this. But it makes this hard.
You can still make it pay per play. It's not hard. It's impossible. You can still make it. You can still make it pay per play.
How so?
If you, as a property, so you would set
right.
the either a factory, so maybe to decouple it more, you would have a callback.
Hang on, you're breaking up. Oh, I can hear you again at least.
Huh.
That was weird. That was your end.
On YouTube, my video is stuck.
Yeah, no, my stream to YouTube is green. It's like the Skype call itself is like is janky.
Oh, good. It's still working on YouTube.
Yeah, it came back like eventually. You just
Did
very
it go
pixely
away?
now, and you
disappear on your screen.
You'll turn up
I can't see
eventually. This is what happened before. You'll come back eventually. The NDI will catch
Interesting.
up, but your audio is still coming through.
So the way you would do this to decouple it completely
Yeah.
is you could set a property. You have a property on this that's like initialize async or something generic that's like initialize, and this thing has on the HTTP context, right?
This thing has a property on it, a nullable HTTP context. So if you invoke it via a result, it'll always have it, right?
So you could basically give the person that instantiates a slice a callback that they can set that runs during execute.
I see.
And then
a second phase, basically. So there's construction, and then there's a pre-execute phase. And so whatever mechanism I generate, there you are. You finally came back. Whatever mechanism I end up creating to the thing that calls activator create instance, for example, and that will also have to have a callback. Did you say?
Sure.
Oh, you're breaking. I can hear you. It's just that like your Skype call keeps weird. I can hear you. You kind of here and there. Oh, I think we might have lost him this time for real. Every now and then I hear a keyboard keystroke come through. I can hear you. Every now and then I can hear you. Very strange. Weird. See if we can get him back on the line.
Can that work?
I mean, I can hear you and see you. You're in the Skype call.
Yay!
So strange. Oh, and you... Why are you up there? There you go. Yeah.
All right. So...
You said basically introduce the concept of a pre-execute somehow.
Yeah. Add a method that just runs whenever execute runs.
And this is only used in the context of an iResult when you're using a slice as an iResult. If you're not using the slice as an iResult,
it'll be null.
I see. And so I just update the execute method to call this delegate if it's set. I just set a property on razor slice, some private internal thing. If that's there, call it AC.
Yeah.
That works. So
that decouples
right.
this from like
right. And what am I setting? What is it?
The code that loops over the thing
and it accepts an iService provider. Is that what you're saying?
It doesn't have to. It could just read it off the property.
Oh, okay.
Yeah.
So basically, this method would change.
Yeah.
So this method would change to be set the HTTP context and then call like this dot pre-execute.
Yeah.
And it just does that.
Yep.
And that method had been set during. When did that get set?
After create instance. So like during the call to create slice, you set the model, you set the pre-execute method, and then it just gets called from there.
It took me a long time. It's just a lazy initialization of these properties. That's basically all it is.
And it's keeping it clean such that you don't have to bake in the concept of setting properties in this code path.
And then the actual execute method, which is let me think. It's gonna run it blah blah blah. The heck is it? Oh, this one here. So this ends up calling down to the razor slices actual execute method here, right? Mm-hmm. This is the generated method. I can't change this.
Yeah.
So I can create a wrapper method though, which is like execute async impl that calls this. And
why?
What?
On the Don't do it there. Just do it on the HTTP context thing. Do it in the execute of the result thing.
But what happens when you instantiate a razor slice outside the context of it being a result?
Who injects properties today when that happens? Exactly. Does that work?
Yeah, the factory takes an iService provider.
If you have a partial that has injects used from a top level thing, what happens?
Yep. Yeah, that doesn't work.
Do you set? Okay, I was like, who sets those things?
Yeah, that doesn't work because it's gonna try and create the partial with its service provider, and its service provider will be null, right? Because no one ever set it because its factory wasn't set to, and its factory it just doesn't have one. Now
your shit is broken.
No. Listen, what happens is the whoever created the original slice creates it with the factory and then sets its service provider property and then calls execute.
Does that flow?
Yes, it flows. Yes.
Partials?
Yes. So that's how it works. Yes. So there's a render to partial method that you call from your view, right? So if I go to like my to-do.
But that would work in the case where you came from an HTTP.
Right. So it's designed to work in the sense that once you get into any slice, you have a property that's the service provider, and that flows.
Then it works, and there's no change that has to be made.
Yeah. Basically, the pattern is you have to set the service provider or the HTTP context because you can get the service provider, the HTTP context. As long as you've done that before you call execute on the root, everything else will work because you have a service provider at that point.
That should work then.
Yeah, so it should just work. Okay.
So you have two modes. One is like horrible to use.
One is the unbound to ASP.NET
manual
mode, right? Yeah, one is the like I can just like get a slice and call execute, but if I didn't set its service provider property, if it hits any partial that has injectables or it has injectables, it'll just fail, right? It'll go nope, but I don't know I can't do that because you didn't give me a service provider. Did you freeze again, or are you just thinking?
Thinking. Still here.
Reveling in the jank. Yeah. Okay.
Not here. In the other one. HTTP one. Don't put it here.
Yeah. Okay. Yeah. So in here, this, after setting the context, because that also is the service provider, you call whatever the pre-thing is. And like it's basically lazily initialize my properties, please. My injectable properties. But we just wrap that in a generic initialize method. I can have that grow up over time. Okay, so like today, that would be crap. Okay, so basically if I go back to this method where I'm currently using expressions to build out these slice factories, so here's what I'm generating, right? Instead of, if I find the one that's generating the properties, get factory with properties, loops through the properties, creates an expression to set all the injectable properties, right, for each property. Yep. Basically, this doesn't go into the factory. What goes in, I have to generate a different expression, which is basically a lambda that gets set to the property that then will get called by someone else later, right?
That sounds too fancy. All you're doing on your thing is adding an action callback. It's a literal action that does nothing.
Yes.
And then the action
but the body of that, the instance that I have to create will be some reflection
property and property
will be
set value
in the course
set value.
Yeah, but the I can't reference the property. So like in Corsiolamo mode, it'll be what's that?
Simple. It's just set value.
Yes. Yeah. But in Corsiolamo mode, I want to generate that so it's compiled.
Right, but that happens. So you want to fix this I see. So non-AOT mode.
Non-AOT mode.
So when you call this thing, it does.
Correct. Basically, this for each loop I have right here.
Yes, you want to call
that gets extracted to build a lambda that gets set on a property in this one. Yep. And then when it gets run, it'll just set the property, and then someone has to call that property. And then in the native AOT version of this code, it's just reflection. Like you said, it's just like it just sets a delegate that literally it's just I just co-generate the freaking delegate, whatever it was, we talked about with source generator, what we said before, right?
Yep.
Yeah. Okay. So then that means we can do lazy property initialization so that you don't pay for the cost of instantiating the request scope service container if you don't need it. That's what all this is about. It's just one layer of indirection. Yep. Okay. Yep. That's good. Okay, so I know how
allocating. Well, I mean, I guess you only allocate in the case where you do have this need.
You allocate a delegate.
Yeah. Can you avoid the allocation?
Can it be static? Can it be a static delegate that's generated?
I think so.
It can, right?
You would have to pass in the service provider
to the delegate. Yeah.
Yeah. Then it can be static.
Yeah. Yes, that's true. Yes.
They have to capture.
Even though the slice instance has a service provider or it's on the context, okay.
If you want the method to be static, if you want the delegate instance to be one
so that you
for
don't
the entire thing,
you
need to stash that.
I need to stash the delegate somewhere.
Yeah. Mm-hmm. So go to your programs, yes.
Yeah, where the pseudo generated code
and add slice 0 action
or initialize or whatever. Yeah.
Mm-hmm.
And then this would be
iSearch provider as the input.
Oh, that's what we're saying.
Mm-hmm.
But yeah.
And this does that for loop over slice props.
And this is literally generated because this is the stuff that's generated. Yeah. Okay.
But it's the same code for everyone though.
Did we say that this code gets generated for everyone? We did. Did we?
Yeah, but it's one per call.
No, sorry. I mean Corsiolaro versus native AOT. They both do this?
No, Corsiolaro is more optimized.
So Corsiolaro, I don't generate this at all?
Do you want to use this same source gen for both modes?
I'm asking, do I even need source gen in the Corsiolaro mode? Is that where we got to? I think we did, right? We said, let's assume this is always generated.
Okay, so assume we do that.
And then, but
in
then
Corsiolaro mode, you could do a lot.
Yeah, but then I need like a branch. I need branching in here, right? Based on runtime feature. No?
Depends. Yes and no. Okay. If you can detect AOT at compile time, you could just generate different code.
Oh, I could just change what gets generated. Yeah.
So you don't have to do the branch at runtime.
That's a really good point. It means during inner loop, you'll be running on Corsiolaro with the slower code, but who cares? It's inner loop, right?
Yeah. Or you just use the publish AOT flag.
Well, that's what I assumed you meant by detect, if that it's published.
Then even in dev, you would do the source gen for AOT stuff.
That's what I mean. Yeah. So
I see. You'd be using the slow mode even when you're
when you're running in a loop with publish AOT true, it runs on Corsiolaro, but you'd be running the native AOT optimized code, which isn't actually optimized in that case. But that's fine.
It's kind of weird. Yeah, but
yeah, but that works. I mean, it's in line with the whole run it like it will run.
Idea.
Like it'll run like it will run after you've published. It just means that it'll be a bit slower because it's reflection, but it's in a loop. Who cares? It's fine. All right. All right. So basically this will either generate this if it's native AOT, or if the flag is not set, it won't generate activated create instance. It'll generate something else. Like we'll have to do the...
It would probably do the same.
The factory thing.
I wouldn't instead
do
of having
this.
these
I wouldn't
calls,
do this.
you would just have one factory per
Yeah,
method.
I wouldn't do this. I don't need the type. I just need... This needs to be slice_0_factory. And I just generate the thing I do today at runtime. I just do it here.
To be fair, maybe you could just generate a slice factory here too. I don't know.
Just always? Is that what you mean?
Yeah, I'm thinking, would that work? There's nowhere to... You need to run code to create the factory. That's the problem.
Yes. Yeah. You'd want to make it lazy or something. And then, like, literally a lazy of slice factory.
Yeah, that's fine, I guess.
I mean, blocking, so it's not great in a web app, but...
Would this work? I'm not sure. No, I am not sure.
Which part?
If you generate, like, no, it doesn't help at all.
No?
I don't think so. What's the input for a slice factory?
Depends on the depends on... It's one of...
F12 is nonsense.
Oh, nothing. Slice factory is the plain one. But there are 4 versions, as you can see. If you have services, then it takes a service provider. If you have a model, it takes a model. If you have both services and a model, then it takes both.
Yeah, I'm not sure if this helps.
No. So remember, the original purpose of this was that you can statically get this today.
Oh, wait.
This only helps if I can generate code that builds this, like...
Yeah.
Right? Like, once. Well, but I can.
I was thinking of unifying this. Like, you basically want the code that's in the body to be in the slice factory instead. And then you just call it from there.
Code that's in the body. Yes.
That's currently in the body of slice 0. Like, maybe
here.
maybe that's the slice factory. Maybe that you put that in there.
Right.
Does this return the slice?
Yes, slice factory returns the slice.
Maybe this is what we generate then. So write the pseudocode.
So you get rid of that and do this. Right?
Yeah.
Oh, this one is a of-T model. For God's sake. Oh.
Ooh,
can't do that.
Problem.
Can't do that.
Undo.
Yeah, it doesn't work. Otherwise, I need to generate a bunch of them. Types. I mean, I could do nested types. And
I need to ask about if we figured out generics yet. I think this actually is the thing that needs to be solved.
Interceptors doesn't support generics, right? We're not doing it.
It might need to.
I thought they had said they weren't going to do it in 8.
I mean, you mean for our source gen?
No, for the feature, interceptors will not support it.
Really?
Yep.
The problem is the call site may contain maybe in a generic class.
Yeah.
And how do you capture that information?
Can't.
Even if the method itself isn't generic, you can't get the surrounding.
It's not captured, right? Like
context.
It's a different context. It's gone. That came up in the thread in the.
I was thinking about that.
So I mean, for this, it doesn't change.
That's fine. This is fine.
I mean, we got to here because we were like, okay, there's still 2 code paths. There's still the core CLR based path and the native AOT based path. we were like, well, you just generate different code based on whether the app is
that's fine.
right. So this is the native AOT version because I'm using activated create instance, and I'll use the property, the initialized property, right? Is that what we said?
Yeah.
Oh, this method here.
The slice dot, yeah.
Right, and this would have the
for each
loop over
P
the
and properties set value.
Oh, this literally, hang on. So in the native AOT, you're saying doing this via reflection is fast.
Faster than generating an expression tree.
Really?
Yeah.
So I just do like for each var prop in slice underscores 0 underscore props. I just do this.
Yeah.
Interesting. Dot set value sp dot get service type
prop dot property type.
Prop dot sorry, not type of prop dot property type. What's the second thing it's trying to? Oh, there you go. It's literally
the instance.
And then down here.
Oh wait, you need the slice instance too.
Oh, the target. Oops.
Yeah.
Yeah, that
first is target, second is value.
First is target, second is value. Yep, that makes sense. And then we would call
that's action, I guess, action of
that action of razor slice.
The slice.
Right, and then it doesn't matter, right? It's all late bound anyway.
Yeah, slice dot whatever nope. We don't call it. It's just slice dot whatever this.
Oh, I'm sorry. Wait, what?
Slice dot callback or whatever you want to call it.
So how did where did this get
slice dot init equals?
Oh yes, it's lazy. Of course.
Equals this slice init thing.
Pre execute. Yeah. Okay.
Yeah.
Okay. And this is an internal property, right? Would be the point.
Yeah.
I see. Nice. Okay.
Yep.
Nice. That works. That works. That's it. That's all. I mean, that's it. But yeah, you creating the slice. It's always a parameterless constructor. That's fine. Creating the slice just means finding it. And then there's two other things. Does it have a model, and does it have properties that need to be set from the service provider? This covers it. This is the native AOT version. This is all being done in the interceptor. So
yeah,
interesting. So that means in the native AOT version, this is easier because I'm just there's no cache or anything. Like this is the cache, right?
Yep.
And then in the core CLR version of this, I have to basically have one of these for this, right? I have to have a slice.
Oh wait. This doesn't work.
Okay.
We need to have a map, a dictionary.
We do?
You can't not have one, yeah.
For the ID. I haven't even I need to map the ID to the slide. Yeah.
Yeah. It's not that you have to map the ID. It's
that you
don't always know it statically.
Have to know. What does that mean? What do you mean? Because I need to decorate this with the right line interceptions and stuff based on the string value, right?
Right. No, so that's the problem. So
right?
You're changing. Yeah, this doesn't work at all.
No.
You need a map.
Okay. So this won't work. This needs to refer to a map that I generated.
Yeah.
To a thing. So I will need to generate this method in a map, just like we do in minimal.
The body, yeah.
Yeah. So there'll be a big dictionary of string to this, basically. And then I'll...
String to...
whatever this is.
Hold on.
Yeah. It's very similar to what I do already internally, actually. Because basically, it'll have a delegate property. And then I'll look at, based on this signature, I generate the code that says, well, it has a model. So if the delegate is not of the slice factory, like the delegate type that takes a model, then throw, because that should never happen.
Yeah.
Yeah, right? Otherwise, cast it to that func type and then invoke it and passing in the model, right? And that's it. That's basically, because everything else here, yeah, that's it.
Yeah, the call site thing doesn't help here at all, actually.
That's it. The problem is, like, where the hell is the map?
There's no point trying to intercept methods.
There isn't? Okay.
The only thing you gain is that you can automatically call the routing method on their behalf.
Yes.
Because
That's
the
what it
issue
does.
is there's nothing in the call site that you generate code based on.
No. Well, no. No. It's literally the call site has the key.
The key, yeah.
That's it, right?
So it would only work if you knew this call site had a static key. Otherwise, you would have to fall back to the slow path.
I see.
So if you declared a variable and set a value in there and then call the method, you cannot do anything to make that like efficient. That requires a lookup of the name because the name isn't known statically. Versus if you hard code strings.
Oh, because we're doing slices. This is not like mapget. Oh my god. I just realized penny just dropped.
But you can do it if there's a string constant.
Okay, so hang on. This constant.
Yeah, so if you know it's a string constant,
which it is almost always,
you can emit the code. It's
I
not
can
a string
emit
constant. That code,
this code.
Yeah.
So this will work in that case.
Yes. If you don't have a string constant, then you have to use the ID passed into you.
Understood. Okay. So this is basically, I don't need this in this case.
In this case.
What's going to happen is I'm going to decorate this with some intercepts thing.
Location, yeah.
And the location and... Okay. Because the mapping happened in the source generator's logic. That's what created this and this, right?
Yep.
And then the mapping becomes the intercept. This is the key, effectively, in this world.
Yeah,
right? Like,
exactly.
The ID gets elided. It's gone. You don't need it anymore because all that got evaluated at compile time.
Right.
And so then when this breaks down is if you're passing in a variable for the ID.
Right.
Because why the hell would you do that? But okay, so you did. Or you and
a non.
I mean, I can
variable.
follow it, right? And
you can only resolve constants.
Yeah, I can. As long as it resolves to a static read only or a literal, right? I can follow it. It could be a static class with a bunch of constants on it, so that the people, so that could work. Yeah. So as long as that works, and then I could just say if you don't do that, I could just say no.
You could actually you could squiggle.
Yeah, just say we don't do that. Doesn't work.
Only constants. Yeah.
Yeah, only constants are supported. Because if I don't do that, then I'd have to generate a map somewhere. Like this would have to have a static map on it, right?
Yeah.
And all this body would have to go into there. Yeah, okay. But to your point, that could be done. The source generator can just do both.
Yeah.
It can do the fast thing when it does it, and it can fall back to the lookup to the map when it doesn't. Okay.
Yeah.
It's just a lot more complicated than...
More complicated.
Okay. And then in the case of core CLR, I have to... The other problem, the extra work is in the case of core CLR, I can't just do this. To make it fast, I have to... I need to create compile an expression that takes the place of activated.create instance.
Yeah.
No, the whole thing, actually.
The whole thing.
The whole damn thing. I don't do any of this stuff.
Yep.
Right? I have to do what I'm doing right now.
Yep.
And then... and okay, so sorry. So that would be... I'd have static read-only slice factory slice. That's when I would do this, right?
Yeah.
And then
but
because I can do that statically.
Yeah, and you don't have the generic argument. So I'm assuming
that's fine.
I'm assuming all the views derive from razor slice, and you don't need
ultimately they do. Yes, even if they're razor slice of T, that derives from razor slice.
Yeah. Then you could...
No, this doesn't work.
Why?
Because to invoke this, I need to cast it to slice factory of T.
You can cast it in the call site.
In here? Oh.
Oh wait, hold on.
No,
I
can't.
Hold on. You don't have T at all. That's the issue. But how do you get T today? Like you don't have it there either.
I generate an expression. I create an expression that's the constructor using... I know the model. Like, I know it, right?
What is it typed as?
It's typed as the actual model type. It's whatever's declared by the razor slice.
But that's not... But in your code, you don't have a hard reference to their type. So how do you get...
What I generate a delegate that is typed as slice factory of their T. Because I can generate that lazily, right?
But that only works in a generic context.
Yes.
So how does that work? Does that happen lazily?
You have to call
during the call.
You have to call razor slice dot resolve slice factory or razor of T or razor slice dot create of T and give it the path and the T model.
Then it happens lazily, right?
Yes. Like you have the roots always have the generic in the current model. Like you always have to call a method that is generic. If you're dealing with
then you would have to store a map. You can't do fields.
For this, right.
And you cast after you resolve the non-generic thing.
Cast to what?
So like you can't
the call site has to.
You can't generate any code in fields.
No, that doesn't work at all.
Yeah. You have to generate a code in the method body and cache it. Because this is the only thing that has the actual generic T model inside of it. So if you have to generate
I see what you're saying. I see. That's fine.
Yeah,
that's fine. That's fine. Hang on, that's fine. I can do what I was doing. This can just be a delegate. And then this thing just casts it to slice factory of T.
I don't think so.
That's exactly how I do it today. That's literally how I do it today.
How do you emit the code?
I'll show you. So look, this is the global dictionary today, right?
Yep.
This has a delegate on it. That's the factory. Sometimes it's a slice factory of T, sometimes it's not. Then you go in through one of the create of T model. Well, that's not the right one. I need the one that takes a slice name.
Sorry, no, this makes sense. Instead of looking at my key, you still have to have a map. Nothing here changes.
I have a map. Yeah, I have to have a map like I do today, right? Well, no, why can't I do this?
You can only avoid the map if you don't know the constant string. If you do know the constant string and you can generate the code for that, then you can.
Same thing we said before.
Yeah, but it is messy, right? Like you have to write that code to double check, lock, and set the value. I mean, lazy, whatever. What's it called? Lazy initializer that whole thing.
For this thing here, you mean? Like literally creating this thing here.
For that, yeah. For setting the value.
For setting this value.
Yeah.
Why can I not just do that in? I can't do it statically, right? It has to be an invocation. Why does it have to be an invocation?
Because you need a T.
No, I don't.
You do.
I don't. I don't do it. I don't have it today. Huh?
You do. You create the delegate on the fly during the generic call site. So someone calls create.
Is that how it works today? No, it doesn't.
In your thing, when someone calls resolve, it does.
It looks up the delegate that was already created in the static constructor. In my map. The map is populated in the static constructor. Fully populated. It's a read-only dictionary. And then I look up, given the ID, the string, I look up the delegate from the slice definition in that dictionary.
So show me that code, because how do you create...
Oh, that's what I was trying to show you. Yeah. So there's a get slice factory method of... There's one that...
you do type of slice factory that make generic method?
Yep, I literally do. Hang on.
Yeah,
okay.
You do.
Yeah, see right there.
You do.
Yeah.
I see.
So I generate all of this lazily, right? I know it. I make,
Yeah, then I guess you could just do that.
Yeah, it would just work. So I can just have a delegate here that's literally like that code, and then I just cast it to the right one because I've got the T. I'd have a method
that would work.
With the right T. It would just work.
That would work, yeah.
Yeah. Okay. My dinner's ready.
Yeah, me too.
That was fun.
Oh my gosh, this is gonna be hard.
Yeah, I know.
And you still have. We may have to change the RISC compiler to make this not be terrible.
Which part?
So we can just source gender properties.
Oh, look! If there was a way to make these types just in the app,
speakable and in the app, yeah,
then I wouldn't have to source generate anything, because the type would be in the call site, right? And then I could just do normal caching, runtime caching stuff. That's my assumption. I wouldn't have to root anything. And it would just be caching a bunch of reflection calls and stuff to set properties and things. That's all it would be. But yeah, until then, I got to do it.
Time to eat.
All right. Catch ya. Bye, everyone.
Yeah.